to Earth Educational Channel. Okay, so good morning and good afternoon and good evening to anyone who is watching this channel. So this is in this video I will discuss everything in English. I will also upload a video in the same name channel in Hindi. So who are comfortable in Hindi, they can go and watch that video. And those who are comfortable in English, they can watch this video, because in this video I will be speaking in English only. Okay, and we will be discussing the number system. This is the first chapter in class 9's mathematics. Okay, mathematics subject. The first chapter that we'll be discussing is number system. So you know that you have learned from your childhood about numbers: 0, 1, 2, 3, 4, and so on. Okay, you went up to 1000, then you knew about 10,000, then lakhs, 1 lakh, 1 crore, and so on. Okay, now so there are trillion, billion. Okay, so you know about these numbers, you have learned about it from childhood. Okay, these numbers. Okay, so the system in this chapter, what we are the classification of these numbers. The classification of these numbers, we are going to learn about this in number system. Means what type of numbers are these. Okay, this number system is a chapter in which we will learn about what type of numbers are these. Okay, so let me take an example. In childhood, when you are 2-3 years olds, your mom would not be giving you any money, so you had zero money with you. Okay, you had zero money with you. Then after 3 or 4 years, your mom started giving you some money in coins. I think 1 rupee coin, 1 rupee coin, then 2 rupee coin. You got 5 rupee coin. Okay, 5 rupee coin. Then you got 10 rupees note, 10 rupees note. Similarly, 50, 100, there were 500, 1000, even 2000 notes were there. Okay, so you got this money. Okay, so if you wanted, suppose if you wanted to give a shopkeeper in 65 rupees 65 you wanted to give, there were many ways of giving rupees 65 to him. You would give him like 6 10 rupees note and 1 5 rupee coin, you can give. Okay, or 1 50 rupees note, 1 10 rupees note plus 5 rupees coin. There are a number of ways you can give this 65 rupees to a shopkeeper. Okay, now if the bill was 65.5, what would you do? How do you give? You would give him 65 rupees plus a 50 paisa coin. The new this generation students might not have seen 50 paisa coin. This might happen. Okay, because it is being phased out, because now not much things are available that is for 50 paisa now. A single chocolate also costs rupees 1. Okay, so that was 65.5, so you give 50 paisa coin. Okay, so what is this 65? Then there is 65.5. Okay, now you can get, in some cases, like you would have studied in some physics, like in temperature. Okay, you take for example temperature in ice cold areas. In ice cold areas, the temperature is negative. The temperature is negative. Okay, you get minus 43 degrees Celsius. So not Celsius, you get 43, minus 2, likewise. So what are these numbers? 65, 65.5, minus 65, minus 65.5. What are these numbers? Okay, so we'll learn about this. So the first number that we are the type of number that we are going to learn is integers. See, integers. integers. It is denoted by z. Okay, and integers are made up of what? They are made up of positive and negative numbers which have no decimal point along with 0. Okay, so let me repeat it. Integers, they are made up of positive and negative numbers which have no decimal point. Means the numbers which have no decimal point, in their decimal point it is 0. Okay, and along with number 0, it all integers also contain the number 0. So if I write the set z, okay, integers, somewhere it is I also, I can say integers, it is denoted by z. The set represents from minus infinity, it will go on like -3, -2, -1, negative numbers, negative integers 0, then 0, then 1, positive integers 3, likewise to positive infinity. See, there are two infinities. In the negative side also there is infinity, in the negative side there is infinity, in the positive side also there is infinity, in the middle there is 0. Okay, these are positive integers. Positive integers denoted by z plus. Okay, these are negative integers. These are negative integers denoted by z minus. Okay, if z minus is written, it denotes z minus or I minus is written, then it denotes the set of all negative integers, like from -1 to -infinity it will denote. And if it denotes z plus, it means all positive integers, that is from 1 to positive infinity. Okay, all the integers. And you can see we are not getting here 1.1, 1.5, 1.6. No, after 1 there is 2, there is 3, there is no decimal point. Okay, after a number there is no decimal point here. Okay, so these are integers. Okay, then there is a subset of this, that is whole numbers. Okay, we will study whole numbers. Whole numbers contains 0 and all positive integers, and all positive integers. Okay, so these whole numbers, what do they contain? 0 and all positive integers, 0, 2, 3, 4, likewise, and so on to infinity, positive infinity. Okay, so this is the set of whole numbers, 0 and all positive integers. This is called, these are called whole numbers. Then there comes natural numbers. Okay, natural numbers. These natural numbers contains only positive integers, contains all positive integers. If they contain all positive integers, then it should start from 1, 1, 2, 3, 4. Okay, so you can see this n, natural numbers, is also a part of whole numbers. See, except for 0, all the remaining numbers are natural numbers. Okay, and these whole natural numbers is also a part of integers. You can see 0, then all positive integers. Okay, this is natural number, this whole thing is whole number, and this total with negative integers is called is the whole set of integers. Okay, so in the form of set we can say, right, in the form of set, in the form of sets we can write n is a subset of whole number is a subset of integers. I am writing in English here. N is a subset of whole numbers. Okay, and W, whole number, is a subset of integers. Understood? In graphic form, if you go in sets, this is natural numbers. From if you add 0 also here, 0, this is the whole number. Then if you add negative integers, negative integers, this is z. Okay, z is integers, w is whole number, and n is natural number. See, first natural numbers are there, all the positive, all the positive numbers, integers are in natural numbers. Okay, if you add 0 to it, it gives us whole number, and then if you add all the negative integers, it will give us all the integers. Okay, so these are three that we have learned. This is a sign of subset. Okay, so we have learned all what we have learned. These three numbers we have learned: natural numbers, whole numbers, and integers. The next comes rational numbers. Okay, it's a very important. Rational numbers, there are two type of numbers: rational and irrational numbers. Okay, rational numbers, I'm going to write the definition of rational numbers. Okay, so the definition of rational number is a number R is called rational if it can be represented in the form of P by Q, called rational if it can be represented in the form of P by Q, where P and Q are integers and Q not equals to 0. See, a number R, I will explain this definition. See, we are taking a number R, okay, where R can be written in the form of P by Q, means this is a fraction. This is a, what it is a fraction. Okay, it can be expressed in the form of a fraction P by Q, where the number P, individual P, is an integer. Okay, Q is an integer but not 0, except 0 you can write. Okay, except integer except 0, except integer except 0. Okay, so I will take one example like 1.1. See this number, if it is rational or not. I have to check 1.1 is rational or not. So what I will write 1.1 equals to 11 by 10. I can write this thing. Okay, now we see 11 is P equals to 11, belongs to Z, it is an integer. Okay, this is Q equals to 10, belongs to integer. This means, see, this symbol is belongs to, means belongs to. Belongs to, P is 11, integer, Q is 10, is also an integer, and it is not equals to 0. Okay, so yes, 1.1 can be expressed. 1.1 can be expressed in the form of P by Q, can be expressed in the form of P by Q, that is 11 by 10. Okay, so it is a rational number. See, I have explained you what is the meaning of rational number. Now you can see, suppose I take this number 0.4. Okay, 0.4, this 4 can be written as 4 by 10. It can be written as 2 by 5 also. It can be written as 40 by 100 also. see, you are seeing that this 0.4, it is a rational number, you can see same. Okay, p equals to 4 or 2 or 40, q is 10 or 5 or 100. These things are giving the same value, that is 0.4, the same number, same rational number it is giving. This property of rational number is called, okay, because of this property that a number can be written in different forms. Okay, it is called equivalent rational number. Equivalent rational number or fraction. Okay, or fraction. Equivalent rational number or fraction. This is a form of fraction. Okay, then if you divide by 2, both of these, you are getting 2 by 10, 2 by 5. If you are multiplying by 10, you are getting 40 by 100. The same number can be represented in different forms. Okay, now a integer number line. In integer number line, we can denote these numbers in a number line. See, integer number line, 0 is in the middle, then there is negative part, negative integers. Okay, then there is positive integers. This is an integer number line. This is positive integers to infinity. Okay, to infinity, this is to minus infinity. This is a integer number line. Now a real number line. A real number line. Okay, there is 0, there is 1, 2, 3, similar to infinity. This is minus 1, minus 2, minus 3, and this is infinity, minus infinity. Okay, in real number line, in between you will get 0.4, here you will get 1.1. Likewise, in between two numbers, this is important, between two numbers there can be infinite. In between two numbers there can be infinite rational numbers. Infinite rational numbers. Okay, see that as being 0.4, no, 4, you can write it 4 by 10, 2 by 5. These fractions are represented by 0.4 once only in the number line. This 4 by 10 is not represented anywhere again. This 4 by 10 means it is 0.4. 2 by 5 is represented here only. 40 by 100 is also represented here only once by 0.4 in the number line. All these fractions are represented once in the number line by 0.4. Okay, and between these two numbers here there can be infinite 0.1. You see an example, 0.1, 1.1, 1.11. It can be infinite. Different means infinite numbers of rational numbers can be there. Okay, so that is one point. So these are the teachings that we have learned. We have learned 4 types of numbers. We have learned integers, natural numbers, okay, whole numbers, and we have learned about rational numbers. Okay, and we are following the CBSE book, that is NCERT we are following, and we will look into some additional questions. I will see to it that whether I need an additional video for the additional questions from other books, or I will include it in while teaching itself. I will see to it, but now we will concentrate only on NCERT. Okay, so we'll go for examples now. The first example, okay, I'll explain the first example, what it is written. Let it be, I will explain it in the example. So the first example is, are the following statements true or false? Are the following statements true or false? Also give reasons for your answers. Give reasons for your answers. Okay, so the first statement that they have given is, every whole number is a natural number. See, before in this question giving, let it be, in this question only I will make you understand. Every whole number is a natural number. Okay, every whole number is a natural number. So this is the statement. You have to write whether it is true or false. The answer is actually false. And how? See, I am making you understand, and in the next question I will tell you how to write in the exam also. So here the answer is false. Why? See, I have already told you. See, natural number is a subset of whole number, and whole number is a subset of integer. Okay, if n is a subset of w, then all elements of n are part of w, but vice versa is not true. That means vice versa is not true. That means, see, n is a subset of w, means w contains, whole number contains all natural numbers. Okay, but not all natural numbers. All natural numbers contain whole numbers. Why? Why? I have made you this statement. This is natural numbers. All the positive integers are here. Then 0. If you add 0 to natural numbers, we get whole numbers. So 0 is a whole number which is not a natural number. Understood? 0 does not belongs to natural number. So the above statement is false. Okay, as I have told you, this statement you have to understand. See, if a set is a subset of w, then every part of this subset is part of this set. Okay, but the vice versa is not true. Means if n is a subset of w, so all the elements of n are in part of w, but all elements of w are not a part of n. That you can understand. So since n is a subset, natural number is subset of whole number, therefore every whole number is not natural number. If it had been reversed, if it had been written, if every natural number is a whole number, that is true. Every natural number is also a whole number. Okay, but not every whole number is a natural number. But in exam you cannot write these. So how you will write in exam, I will give you. For the next statement I will write it. Okay, you write in the second part. Second question, it is given, every integer is a rational number. Okay, every integer is a rational number. Now again the same thing is appearing. We know natural number is a subset of whole number is a subset of z. Then add integer is a subset of rational number. See, an integer, you mark this point, an integer m, okay, can be expressed in the form of p by q as m by 1, where p equals to m, which is an integer, and q equals to 1, which is an integer. Hence m is a rational number. Okay, in rational number, rational number contain both integers and fractions. See, integers contains no fractions. Okay, only those without a decimal point, those are integers. But rational numbers are what? They have to be expressed only in the form of p by q, where p and q are integers and q is not equals to 0. So an integer m, Okay, like suppose 5, I can write 5 as 5 by 1. So this is P, this is Q, and it is satisfying. We can write it as P by Q, that is 5 by 1. So every integer can be written in this form. Okay, so we can see that integer is a subset of Q, means integer is a subset of rational number. Okay, so since here it is written what, every integer is a rational number, so that is definitely true, because since z is a subset of Q, hence every integer is a rational number, okay. Every integer is a rational number, that you are getting it. In rational number, all the integers are already there. In addition to the integers, there are fractions also. Okay, like the subset of Q can be written as C, like this: -4, -3, minus like infinity. Okay, -2, -1 by 4, -1, 0, 1 by 4, 1, 2, 3, and so on to infinity. See, these 1 by 4, these are missing in integers because these are fractions. Okay, but these are present in rational numbers, but these are part of integers. So all integers are part of rational numbers, but all not rational numbers are not part of integers. Okay, so that is the second. Then the third statement, what it is given, let me see. In the third statement it is written, every rational number is an integer. Every rational number is an integer. The same thing. See, every integer is a rational number. Now it is given that every rational number is an integer. We know n, w, this relation we know. Okay, so since I have already said about it, see, z is a subset of Q, so the above statement is false. But in exam you cannot write this. Okay, so in exam what you will write, I am telling you. See, you will write what is z first. Integer, it has told me about integer, and it has told me about rational number. We have to write about every integer and every rational number. Okay, so first we'll define integer. Integer contains all positive and negative numbers with no decimal part. Fractional part you can also write, with no fractional part, along with 0. The set of integers can be represented by as such. The set of integers can be represented as such: z minus infinity to -3, 2, -1, 0, 1, 2, 3, so on to infinity. This is the set of integers. Rational numbers are those numbers that can be represented in the form of P by Q, where P and Q are integers and Q is not equals to 0. This part is very important, that Q is not equals to 0. Okay, Q is not equals to 0, so Q can be represented in the form of set as the set of rational numbers. The set of rational numbers can be represented as such. Okay, minus infinity, -3, -2, -1, -1.4, 0, 1 by 4, 1, 2, 3 and so on. From above sets we can see that Z is a subset of Q. So all elements of Z, that is all integers, are part of Q, rational numbers. But vice versa is not true, because fractions are part of rational numbers, while they are not a part of integers. Okay, so this is the way you will write in exam. So in the above two questions I have explained you why it is happening, why it is true or false, and in this part it is false. Okay, here I have explained you how to write it in the exam. Okay, then we will go to the first exercise of NCERT, exercise 1.1. The first question: is 0 a rational number? Is 0 a rational number? Can you write it in the form of P by Q, where P and Q are integers? See, this is the question that they have given. If 0 is 0 a rational number? So the answer, again I am telling you, in exams you have to explain each and every step that you are writing. Okay, via brackets, in since you have to explain why I have introduced these numbers, why, and everything what you have done you have to write using since. Okay, in the brackets or in the statements above what you have done, you have to write it and explain. In CBSE you have to do it, in ICSE you don't have to do it, in CBSE you have to do it. You have to explain every step that you are doing in maths. Okay, so is 0 a rational number? I am explaining you why it is a rational number. I am not giving you, because if I start writing answers in the form of CBSE, the video will be 10 hours long. Okay, so I'll be explaining you only. You have to write it with every step from, or you can make your own notes. Okay, with my what I am telling you, you can make your notes, because what I am telling you, that only you have to be written. I am not writing it because it will take more time. Okay, so I am explaining you why 0 is a rational number. See, 0 can be written in the form of 0 by 1. Okay, that 0 by 1 is 1. Sorry, 0. 0 by 2 is 0. 0 by 3 is 0. 0 by minus 1 is 0. 0 by minus 2 is 0. 0 by 15 is 0, and so on. Okay, so you are seeing that if 0 by 0 is 0 is written as 0 by 1, it can be written in the, so P equals to 0. Here P equals to 0, and Q can be any integer. Q can be any integer which is not 0. Okay, if P is equals to 0 and Q is any integer which is not 0, it gives the value 0. Hence 0 Hence 0 can be written in the form of P by Q, where P and Q are not integers. Okay, you are seeing, these things are equivalent. How you have to write this 0 by 1 gives value 0. 0 by 2 also gives value 0. 0 by 3 also gives value 0. these fractions value is 0. Okay, so we are seeing that we can write 0 by 1 as a rational number. So in the form of p by q, and q should not be 0 if both 0 by 0 is undefined. Okay, 0 by 0 is undefined, so q should not be 0. Q has to be any integer, be it positive or negative, except 0. It can be anything. Okay, this is not right. P and q are integers. P and q are integers, so 0 is a rational number. This is the first question. And I forgot to mention one second example that I have given. I will mention it here itself. Okay, so the same question, the example and the exercise question is same. Okay, only the numbers changing. So second question is find 5 rational numbers. Find 6 rational numbers. 6 rational numbers. Find 6 rational numbers between 3 and 4. Find 6 rational numbers between 3 and 4. Okay, so as I have already said, okay, there are infinite rational numbers between two numbers. Rational numbers between two numbers, be it integers or even rational numbers, be it between any two numbers, there can be infinite. But we will see a method where we will get only 6 rational numbers that we want. Okay, there can be infinite, we only want 6, so we'll let only the 6. Okay, in exam you have to do it this way only, because otherwise you can write 6 numbers or 7 numbers, 7 rational numbers between them, but you will only be writing the answers. There will be no method, so you may not get marks. So using this method you will get 6 rational numbers and you will also get the marks. So see, here we have to get 6 rational numbers. So what we will do, we will make the denominator plus 1. Denominator equals to 6 plus 1, that is 7. How many numbers are required, we have to increase it by 1. If 6 is required, then 7. If 8 is required, then 9. Similarly, okay, denominator 7. Now we have to find rational numbers between 3 and 4. Okay, we'll write 3 and 4 like this. Then we'll multiply and divide by this denominator number. See, 6 is required, so 3 by 7. We'll multiply 3 with 7 and we'll divide it also by 7. We'll get the same number. We'll multiply it by 7, we'll divide it by 7. So here what we are getting? We are getting 21 by 7. Here we are getting 28 by 7. Okay. We will find, see, if we increase the numerator 1 by 1, 22 by 7 is one number. Then 23 by 7 is one number. 24 by 7 is one number. 25 by 7 is one number. 26 by 7. 27 by 7. Okay. 21 by 7, this is 3. Okay, equals to 3. If we increase 21 plus 1 by 7, this is 22 by 7. Okay, if we increase 21 plus 2 by 7, this is 23 by 7. Likewise, you are getting to 21 by 6. This is 27 by 7. Then you are getting 28 by 7. That is, you are getting, this is 4. Okay, so these are the 6 rational numbers. 6 rational number between 3 and 4. You are understanding the process. The number, we have to find 6 rational numbers, so we'll increase it by 1, that is 7. That will be the denominator. And between the two numbers that it has been said to find the rational numbers, we'll multiply and divide. Means 7 we have got, we'll multiply 3 with 7 and we'll divide also with 7. Okay, and we will do the same thing with the other integer 4 into 7 by 7. Okay, so we'll got 21 by 7, 28 by 7. We'll increase the numerator by 1 every time. We'll increase the numerator by 1 every time. So we'll keep on getting 1 numbers. See, you can make that 6 as 8 also. You have to find 6. If you make it as denominator as 8 also, what you will get? 3 into 8 by 8, that is 24 by 8 you will be getting. Here you will be getting 32 by 8. Okay, so here you can get 6 rational numbers here also. Okay, but in total, see, if there will be 8, if you are making it 3 into 8 by 8, okay, here what you are getting? 24 by 8. Here you are getting 4 into 8 by 8, that is 32 by 8. Okay, so in between numbers are what? 25, 26, 27, 28, 29, 30, 31. You are getting 7 rational numbers. 7 rational numbers. Okay, 7 rational number. You can choose from these 6, you can choose and write. That is also the correct answer. But in this method, directly you are getting the 6 rational numbers. So the teacher will understand that yes, you know the method on how to calculate directly 6 rational numbers. Okay, not extra or not less. If you make it 5 also, you will get, but you will get in here 5 rational numbers. You have to find one more. Here getting one extra. If you make it less, you will getting one less. Okay, so this is the method of writing. So as always I will tell you, write it in proper steps, like why you are doing this. Every step why you are doing, you have to mention it in the exam. Okay, I am writing you the steps to make you understand, but in exam you have to make it, you have to write how the invigilator will understand why you are doing a particular step. Okay, find 5 rational numbers. That is the third question. Find rational numbers between 3 by 5. C, between 2, here it has given between 2 rational numbers you have to find 5 rational numbers. Same theory, nothing. Okay, 5 is given, so denominator is 5 plus 1 equals to 6. Then we will multiply and divide the same thing, 3 by 5 into 6 by 6. Here what are you getting? 18 by 30. Okay, similarly here what you are getting? 4 by 5 it is given, you multiply and divide by 6, you are getting 24 by 30. Okay, so if you increase the numerator, 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30. See, 5 rational numbers between 3 by 5 and 4 by 5. How easy? Again I am explaining you. See, 5, we want to find 5 rational numbers, so the denominator number will be 5 plus 1, that is 6. Okay, then the given numbers that I have given, be it integers or rational number, you multiply and divide by the denominator part you have given, found, that is 6 by 6. 3 by 5 into 6 by 6. You do not cancel everything, you will get the same. 3 by 5 into 6 by 6 is 3 by 5 only. Okay, do not cancel, you multiply. 18 by 30 you are getting. Similarly, 4 by 5 into 6 by 6, that is 24 by 30. Between 18 by 30 and 24 by 30, there will be 5 rational numbers. If you increase the numerator by 1, 18 plus 1, 19. Then again 19 plus 1, 20. Okay, if you increase numerator 1 by 1 successively, okay, 18 plus 1, 19, 19 plus 1, 20, 20 plus 1, 21, 21 plus 1, 22, 21, 22 plus 1, 23. And if you keep the denominator same, you are getting the 5 rational numbers. So this is the method of finding the 5 rational numbers. Again I am telling you to mention all the steps how you are finding. Okay, and we are going to the last question of this exercise. Okay, so state whether the following statements, here also statements true or false, following statements are true or false, and also give reason for your answers. Okay, so the first question is, every natural number every natural number is a whole number. Every natural number is a whole number. Every natural number is a whole number. See, I will not be writing the same thing again and again. Natural number, natural number 1, 2, 3, 4, and so on to infinity. Okay, whole number is 0, 1, 2, 3, 4 to infinity. Okay, so natural number is a subset of whole number, that we have seen already. So since natural number is a subset of whole number, so naturally therefore every natural number is a whole number. Hold on. Every natural number is a whole number. Okay, so you have to write it in English. You have to first write the definition. See, definition of natural number, and write this is the set. Okay, then write definition of whole number. Now this is the set. Then you write that natural number is a subset of whole number. Okay, therefore every natural number is a whole number, since every natural number is a part of whole number. Okay, so the above statement is true. Okay, the second question. I have recorded the Hindi video first and then I am recording the English one. So I think I am thinking that I am going a little bit fast in the English version, because I am doing the same thing again. Okay, so if you feel like this is very fast for you and you are not getting it, you please write it in the comment section. I will try that the Hindi videos and the English videos both will be of the at the same speed, so that you can grasp the concept. Okay, in the Hindi video I think that in the answers part I have written it more precisely, and what in the exam you have to write, that I have written, but it was taking a very long time. So that is why I thought that I will tell you what you have to write in the exam. Like here again I have to write the natural number, definition of natural number, but I have written it already. Okay, so there is no point of me writing it again and again. But if you want how to write it in the exam, I will write every question's answers from the exam point of view also. You please mention it in the comment section if you want that, but it will be a waste of time of yours also. Okay, I can give you, see, I am telling you the format in which you have to write the answers. Okay, so you can write it in the exam in that format, but you can practice on your own. Okay, when you are practicing the exercises, you can practice few of them on how you are going to write it in the exam. But if you write every answer, every question on how you are going to write it in the exam, it will be very time taking. Okay, it will be a waste of your time also. So you know how to write it in the exam, and you understand every concept, and you will be able to write it in the exam. You will get 100 out of 100. Okay, no need of writing all the answers every time. In your revision and in your practice time, as you are going to write it in the exam. So that is my viewpoint that I am trying to tell, to save your time also. Yeah, because your time is very precious. Okay, you have so many subjects. Like I am teaching maths only, but you have to read science and everything. So how in every possible way you can save time, and you can uh, learn all the subjects in a good way, so that you can score the maximum marks. And the maximum marks is 100. Not all will get 100, but I am hoping that whoever watches these videos, they will try to get 100 out of 100. Okay, and best of luck also, and I hope you are understanding what I am telling. Okay, every integer is the second question, it is written as every integer is a whole number. Okay, every integer is a whole number. See, I will write whole numbers is 0, 1, 2, 3 and 4 to infinity, but integers also contain negative part. 3 minus 4 means minus infinity is there, plus 3 minus 2, minus 2 minus 1, 0, 1, 2, 3 to infinity. Okay, wz, this is a whole number, this is integers. So whole number is a part of, this is the w, but these are not w's. Okay, so w is a subset of z, therefore every whole number is an integer. but the vice versa is not true. But the vice versa, every whole number is an integer, but the vice versa is not true. So the above statement is false. Okay. See, the whole numbers are part of Z, as you can see, but these negative integers are not part of whole numbers. So not every integer is a whole number. Okay. So again you write the definition of whole numbers here, definition of integers here. Then you mention that whole numbers are a subset of integers. Therefore, every whole number is an integer, but vice versa. That is, not every integer is a whole number. Hence, the above statement is false. Likewise, you write it in the exam. Okay. Then the third question. Every rational number is a whole number. Okay, every rational number is a whole number. Again, see this, the whole mantra is this equation only. N, okay, n is a subset of w, is a subset of integer, is a subset of rational number. See, every rational number is a whole number. See, whole number is a subset, overall is a subset of rational number. So how every rational number will be whole number? It cannot be. See, w belongs to 0, 1, 2, 3, 4, everything to infinity, all the positive integers and 0. But rational numbers contain not only negative integers, okay, not only negative integers, but fractions also, negative fractions also it contains. Negative fractions also it contains. Positive fractions also it contains. Okay. So this is rational numbers. See, this one and this one, these are whole numbers, but there are positive fractions, positive and negative fractions, and negative integers. Negative integers are not part of whole numbers, and we know whole numbers is a subset of rational numbers. Therefore, every whole number is a rational number. Every whole number is a rational number. Every whole number is a rational number, but vice versa is not true. So the above statement is false. Okay, the same thing I've understood. If someone is a subset of some set, if some set W is a subset of the set Q, then every W is part of Q, but vice versa is not true. So that you have to learn. Okay, so this is the end of the first exercise, and I will be ending the video here because it has been too long. Okay, from the second chapter will be on irrational numbers, so we will look into that in the next video. So you can mention in the comment section what you are liking about the video and what you dislike also, so that I can correct it in the next videos. Upcoming videos I will try to correct it. Okay, I am pre-recording it, so the corrections will be after 2-3 videos only. Okay, so I hope it is more engaging to you, and if you have any doubts regarding any of the questions or anything, you can ask it in the comment section. I am trying to get a thinking how I can answer all your queries in the comment sections or anywhere. Okay, so I'm trying for something, so I'll look into it. But let's see, you mention your queries and any doubts in the comment section, and whether you like the video or not, mention it in the comment section, and subscribe to the channel for further videos also, and like also. If you found the video to be interesting and useful, please like the video. And till then, take care and have a very good day. Okay, and thank you.